Solving logarithmic equations type 2. Now this is one where you're going to have a log equals a number. So this is when we use our converting between a logarithmic equation to an exponential equation. So if you have log base b of x equals y, then that is the exponential equation b to the y power equals x. Now we are going to have to use our property of logs also and then convert it into an exponential equation. So on this one, on the left-hand side, we have two logs and they are being added, which means it is a multiplication problem. And you'll notice it's just the common log because there's no base mentioned. So I'm going to go 2x times x minus 5, and that equals 2. Now, if you want to, you can put in that 10 so that you remember what our base is, because we are about to change this into an exponential equation. So since I need to write this as an exponential equation, I'm going to have 10 to the second power, because if we look up here, it is the base to the, what our answer is, equals, and I'm just actually going to distribute this to 2x squared minus 10x, and it equals 10 squared, also known as 100. So I am going to have to factor. On this problem, I want to make it equal 0. So I'm going to subtract 100 from both sides because 10 squared is 100. And I have 0 equals 2x squared minus 10x minus 100. If I factor, I first need to say, do I have a GCF? And the answer to that question is yes. It has a GCF of 2. So I'm going to factor out a 2. And I'm going to get x squared minus 5x minus 50. So now I have to ask myself, what two numbers multiply to negative 50 while adding to negative 5? Because this is a diamond problem. The coefficient of x squared is just a 1 now. And the two numbers that multiply to 50 and add to negative 5 would be negative 10 and 5. So we now have 0 equals 2 times x minus 10 times x plus 5. The zero property problem says that if you have things that multiply to 0, one of them has to be a 0. So either the x minus 10 equals 0 or the x plus 5 equals the 0, giving us x equals 10 or x equals negative 5. Now, there's one issue with this. If you plug in a number and it results in trying to take the log of a negative number, then that is not a possible answer. So if I were to plug in a 10 into my original problem, 2 times 10 is a positive number, and 10 minus 5 is also a positive number. So that's an acceptable answer. If I tried negative 5, 2 times negative 5 is negative 10. You cannot take the log of a negative number. So this is called an extraneous solution, and we cross it off. The answer is only 10. So you will have to check if your answer results in a negative number in the original problem. If it does, cross it off. It's not actually an answer. It's kind of like a phantom answer. Okay, let's try another one. So on this problem, I have both log base 6's, and it is a subtracting of the logs, which means using the property of logs, if it's a subtraction, I can condense it by dividing. So I'm going to have x over x minus 9 equals 2. So I do actually have a base on this one, 6. So if I change this into an exponential, that would be 6 to the second power equals x over x minus 9. Now 6 to the second power is just 36, so I'm just going to write that as 36. If I have stuff in the denominator of a fraction and I want to get it out of the denominator, I just multiply both sides by that denominator. So I can do that and I can cross them off, which is nice because now I don't have a fraction. And I'm actually going to distribute on this side. So 36 times x is 36x, and 36 times 9 is 324. If I subtract 36x from both sides, because I want to get x's together, I would have negative 324 equals negative 35x. And if I divide both sides by negative 35, I'm going to get a fraction, or I can write it as a decimal. X is about 9.3 rounded. I could also leave it as the 324 over 35. Now looking back at my original, let's just make sure this answer works. If I plugged about negative 9.3 here, we're fine. And positive 9.3 minus 9 is still a positive number, so it works there also. So that is an acceptable answer. Okay, let's try one more. If I were to put these two together using the property of logs, since it's an addition, that means I'm going to multiply those two. So I'm going to have log base 4 of, and I'm actually just going to distribute, x times x plus 3 is x squared plus 3x, and it still equals 1. Now, since I have log equals a number, I have to use my exponential equation. So I'm going to have 4 to the first power equals x squared plus 3x. Well, 4 to the first power is just 4. So I'm going to subtract 4 from both sides because if I want to factor to solve, I need it to say equals 0. So I'm going to have this, and this is also a diamond problem. So I need to find two numbers that multiply to negative 4 while adding to positive 3. That is going to be 4 and negative 1. So I have 0 equals x plus 4 times x minus 1. And again, if I have things that multiply to 0, I break them apart and one of them has to be a 0. Because the only way two numbers multiply to 0 is if one of them is 0. So if I subtract 4 from both sides here, I get x equals negative 4. And if I add 1 to both sides here, I get x equals 1. Now let's just double check these work. If I plug a negative 4 into the original problem, I would be taking the log of a negative. Not happening. Cross it off. If I plugged a 1 into either of them, the first one would just be a 1. That's fine. And 1 plus 3 is 4. That's fine. So our answer is 1. I will be putting the factoring flowchart into the notes. So if you are not sure how to factor, look at your factoring flowchart, please.